All right, team. So on Monday, you and your partner walked through this worksheet where really you're investigating the answer to this key question. Does adding solute to water change the boiling and freezing points of that solvent? And I think you probably discovered that the answer is yes. So you want to take out this worksheet that says colligative properties on top, and that just refers to the properties of a solvent once you've added a solute. Properties change a little bit, and we're going to go over some of these answers. Then you're going to get a little bit more practice with these ideas of freezing and boiling points so that you can be ready to make ice cream tomorrow. So flip to the second page. There we go. And the first thing we had to look at is how many particles are created when an ionic compound dissolves in a solution. So we looked at some examples. And you can see that this ionic compound dissolves to make 2 particles, but this one, because of this subscript 2 right here, dissolves to make 3 particles, 1 of these and 2 of these. So let's look at a few more examples of this. This one is just like the first example, where you end up with 1 potassium and 1 chloride, and just check yourself to make sure that you have included these plus and minuses. What about a slightly more difficult one? Down here at number 6, we have 2 potassium ions, K2, and SO4, 2-. So this is 2 particles here, 1 more here, so that's 3 particles total. And let's do 1 more. How about aluminum chloride? That's AlCl3. That's going to break down into aluminum 3+ and 3 chloride ions. So that is 1, 2, 3, 4. So 3 there, 1 there. So that's 4 particles. All right, once you can do that, you are ready to use that information to actually calculate the new freezing point or boiling point for any solution with any amount of any solute in it. So we're going to flip over here, and you looked at these 2 examples, and let's go through a couple of these practice problems. I'm going to choose 2 or 3 to take a look at. So the first one we will take a look at is calcium chloride. The formula here is CaCl2, and that's important, and we know that that dissociates or dissolves like this. So we actually have 3 particles. So 3 is going to be equal to I. I is our number of particles. Once we figured that out, we have a number of grams of calcium chloride. We can't use grams. We need to convert that to moles by doing a quick conversion. The molar mass is 110.98 grams per mole, and that gives you 0.315 moles. And now we actually want molarity, because that's what we can plug in. They give you 460 milliliters. That is actually equal to 0.460 liters. So make sure you have these units, moles over liters. And that will give us 0.686 molar solution of calcium chloride. So we have 2 key pieces of information here. We have the number of particles that the calcium chloride dissolves into, and we have the molarity of the calcium chloride solution. So we're going to use this equation. The change in the freezing point is equal to molarity times the freezing point constant times I, which is the number of particles. So the molarity is 0.686. Kf is always going to be the same thing, and if you look up here in the example, Kf is always negative 1.86. It's a constant, it doesn't change. And finally, the number of particles is 3. So if we do this times this times this, you get negative 3.83. So to find the freezing point, we're going to take the normal freezing point of water, which is 0, minus 3.83, and of course that gives you negative 3.83 degrees Celsius. So there's our answer. let's see, what else should we look at here? Let's go down to the bottom of the page. And we're going to calculate the boiling point. So this is a little bit different. We're going to use a KB this time, and that's 0.51. That's at the top of the page. To calculate the boiling point of 675 milliliters of water when 22 grams of potassium nitrate is KNO3. And when that dissolves, we end up with 2 parts, 1 potassium and 1 nitrate. So I is equal to 2 in this case. We have grams again, that's annoying, so 22 grams. And the molar mass of potassium nitrate is 101.11 grams. That will give us 0.218 moles. And we want moles per liter. We have 675 milliliters. Don't you dare put milliliters on the bottom here. We're going to put 0.675 liters. And that will give us 0.322 molar. So now we have all the information we need. We have the molarity. We have what I equals, the number of particles. And we have this handy-dandy equation. The same one whether you're doing boiling or freezing. We just stick a B for boiling instead of an F for freezing. Molarity is 0.322, KB is 0.51, and I is 2. Notice with boiling we don't have any negative signs. This gives you 0.33. And this time, since we know that pure water boils at 100 Celsius, but our change is positive 0.33 degrees, our new boiling point is 100.33 degrees Celsius. So you dump in a bunch of potassium nitrate, the boiling point increases by just a little bit. Let's do one on the back. So flip over to the back page and let's see. Let's do the top one on this page. What is the freezing point of 1.4 moles of sodium sulfate in 1,750 milliliters of water? Ooh, this is actually a slightly easier question. We have Na2SO4, and that dissociates into 2 sodium ions, because we have Na2, and 1 sulfate ion. So I'm going to say that I is equal to 3. 2 here plus 1 more equals 3 particles. So the more particles you have, the more powerful this solute is in changing the boiling or the freezing temperature. And let's see, in this case, they just gave us 1.40 moles. How nice, we don't have to convert to moles. And we have milliliters, so I'm going to divide by 1,000, and that will give me 1.75 liters. So now we have moles over liters, and that gives 0.8 molar. And here we go, we're going to plug into this change in the freezing point equation. Our molarity is 0.8. Our constant, because this is freezing, is negative 1.86. Number of particles is 3. We multiply these 3 things together and get negative 4.46. So this is a big change. This time we have 3 particles, so our change in freezing point is even bigger. 0 minus 4.46 equals negative 4.46 degrees Celsius. Excellent. So you're going to get some more practice on calculating freezing and boiling points today, and then you will be all ready to be an expert at ice cream making tomorrow.